Ever wonder why the sun shines every day, never missing a beat? It's more than just a star. It's the heart of our solar system, pumping out energy that breathes life into our planet. Its warm glow isn't just a daily spectacle. It's the result of a complex life cycle that's been ongoing for about 4.5 billion years. The sun, an enormous ball of burning hydrogen, is in a constant state of nuclear fusion. This massive reaction is the source of the light and heat we depend on. Without it, life on Earth as we know it wouldn't exist. But the sun's story doesn't end there. Its life cycle, from birth to death, is a fascinating journey that mirrors the cosmic life cycles of countless stars across the universe. Understanding the life cycle of the sun gives us valuable insights into the universe and our place within it. Imagine a cloud of dust and gas, a nebula collapsing under its own gravity. Picture in your mind's eye a swirling, chaotic mass, a cosmic ballet of particles dancing in the vastness of space. Over the course of millions of years, this nebula, a celestial nursery, began to contract under the relentless pull of gravity. This nebula was not just any mass of particles, it was a rich soup of elements and compounds, remnants from the death of previous stars. As the nebula contracted, the particles within it started to move faster, colliding with each other and generating heat. The heart of this nebula started to glow, a faint ember amidst the cosmic dust, marking the birth of a protostar. As the protostar continued to grow, the pressure and temperature at its core increased. The heat generated was so immense that it initiated the process of nuclear fusion, where hydrogen atoms began to fuse together to form helium. This process of fusion released enormous amounts of energy, causing the protostar to shine brightly. The energy created by fusion acted as a counterbalance to the gravitational pull, preventing further collapse of the star. This delicate balance between gravity and fusion energy marked the transition from a protostar to a main sequence star. And so, our sun was born. Our sun, like all stars, is a cosmic furnace, a beacon of light and heat in the cold depths of space. But it's not just any star, it's our star. It's the center of our solar system, the source of heat and light that has allowed life as we know it to flourish on Earth. The birth of the sun wasn't a singular event. It was a process that took millions of years. From a nebula to a protostar, and then to a main sequence star, our sun has traversed a journey of cosmic proportions. This marked the birth of the sun, a star that would shine for billions of years. A star that continues to shine, casting its warm golden light on our beautiful blue planet every single day. After its birth, the sun settled into what astronomers call the main sequence. Now you might be wondering, what is the main sequence? Well, think of it as the sun's adulthood. It's the phase where the sun, like any other star, shines brightly, burning hydrogen in its core to produce helium and energy. This isn't just a random process. It's a precisely balanced act of nature. On one hand, there's the force of gravity, constantly pulling everything inwards, trying to make the sun shrink. On the other hand, there's the pressure from nuclear fusion, the process that powers the sun, pushing outwards and resisting this contraction. Let's take a moment to appreciate this balance. It's like a cosmic tug of war. If gravity were to win, the sun would collapse in on itself. But if the pressure from nuclear fusion were to dominate, the sun would blow itself apart. Yet neither of these scenarios happen. The forces balance each other out, maintaining the sun's size and shape. Now, the sun doesn't have an unlimited supply of hydrogen to burn, but don't worry, it won't run out anytime soon. The sun is incredibly efficient. It's been burning hydrogen for about 4.5 billion years, and it still has around 5.5 billion years to go. That's right. Our sun, this beacon of light and life, has been in its main sequence for a very long time, and will continue to be for a time period almost unimaginable to us. That's billions of years of providing light and warmth to our planet, supporting life, and influencing everything from our climate to our cultures. And here's the thing, the sun is not special. It's a pretty average star. There are billions of stars out there, each in their own stage of life, each with their own story to tell. But for now, let's focus on our own star. The sun will remain in this stable state for about 10 billion years. But what happens when the sun exhausts its hydrogen fuel? Well, that's when things start to get really interesting. You see, the sun, like all stars, has a lifespan, and when it exhausts its primary source of fuel, hydrogen, it will begin a transition into its twilight years. At this point, the sun will start burning helium, the product of the hydrogen fusion that has been taking place in its core for billions of years. This change in fuel will cause some dramatic changes in our star. The core of the sun will start to shrink, but paradoxically, the outer layers will expand. This is due to the increased heat and pressure generated by the helium fusion. As the sun continues to burn helium, it will grow in size, eventually becoming a red giant. This isn't just a fancy name. The sun will literally become a giant, its outer layers expanding so much that it will swallow up the inner planets, possibly even reaching as far as Earth. While this might sound like a catastrophe, it's a natural part of a star's life cycle. And don't worry, this won't happen for another 5 billion years or so. But the sun's growth into a red giant is not the end of its story. After the helium fuel is exhausted, the sun's core will collapse under its own gravity, causing the outer layers to be thrown off into space. This will create a beautiful nebula, a cloud of gas and dust that will be illuminated by the remaining hot core of the sun. This core, now exposed, will become a white dwarf, a small but incredibly dense star that will slowly cool and fade over billions of years. This is the sun's swan song, a spectacular end to its life. So even in its twilight years, our sun will continue to astound us with its cosmic beauty. After the sun's outer layers are blown away, what remains? We're left with the sun's core, which transforms into a celestial body known as a white dwarf. This white dwarf, while small compared to its previous gigantic size, is incredibly dense. It's like squeezing the mass of our sun into an area the size of Earth. This white dwarf is a testament to the sun's past, a crystal ball that holds the history of our star's life. It's incredibly hot, with temperatures reaching hundreds of thousands of degrees. But without the nuclear reactions that once fueled its luminescence, the white dwarf begins to cool down. As it cools, it shrinks. Over time, it loses its brightness, and its light dims. But don't be fooled by its waning glow. This cooling process isn't something that happens over a span of a few years, or even a few million years. We're talking about a process that will span billions of years. During this time, the white dwarf will continue to cool and fade, its light growing dimmer and dimmer. Eventually, after eons have passed, it will become a black dwarf. A black dwarf is essentially a white dwarf that has cooled to the point where it no longer emits significant heat or light. But here's the thing, the universe isn't old enough for any black dwarfs to exist yet. The process takes longer than the current age of the universe. So every white dwarf we see in the night sky is a star in the midst of its long, slow fade. And so the sun's legacy isn't one of fiery destruction, but of a gentle, slow retreat into the shadows. It's a testament to the enduring nature of the universe, a symbol of the vast timescales over which astronomical events occur. Even in death, the sun leaves behind a fascinating legacy. It reminds us of the impermanence of things, even stars, and yet, in its tranquil decline, it echoes the enduring narrative of the cosmos. From a nebula to a black dwarf, the sun's journey is truly awe-inspiring. We've journeyed together through the life of our sun, a cosmic spectacle that unfolds over billions of years. We've seen it born from a nebula, a celestial nursery nurturing the birth of stars. We've witnessed its main sequence, a period of stability where the sun burns brightest and gives life to our planet. We've watched the sun grow into a red giant, an elderly star expanding in size and cooling in temperature, and we've glimpsed its twilight years as it shrinks into a white dwarf, gradually cooling and dimming until it becomes a black dwarf. Every stage of the sun's life cycle is a testament to the power and majesty of the universe. So the next time you bask in the sunlight, remember, you're experiencing a moment in the life cycle of our fascinating sun.